Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. Today we are going to learn about Moivre's theorem. Moivre's theorem. And we are going to learn the proof using the concept of complex numbers in their polar form. So Moivre's theorem states that the complex number z raised to an exponent of n is equal to the modulus raised to the power n. So Rn multiplying this cos into bracket n times theta, then plus I sine into bracket n times theta this way. Where theta is what? Is the argument or the reference angle or your true angle, okay? And the n denotes the exponents, okay? So n is just a set of what? It's just a set of real values, okay? Any integer at all, n. And z is your complex number and I is your modulus, okay? So now, let's look at the proof, okay? So we know that to represent complex number z in polar form is equal to r multiplying, we have cos theta plus what? I sine theta. This way, let's multiply this. This is z raised to the power 1. Okay. So let's look out for z raised to the power 2. Okay. So z raised to the power 2 is just me multiplying z times z. If I multiply this twice, it's z raised to the power what? 2. So z raised to the power 2 is the same as z times what? Z, which is equal to, what is z? Z is what? R. Then I have cos theta here plus I sine theta. Then z times z, okay, times another z, so times z, and z is the same as we have r, then you have cos theta plus I sine theta this way. So I have z squared is equal to r times r gives what? You have r squared. Then we have this, you have cos, then theta plus theta. Okay, so you have theta plus theta. Then you have plus, then you have I sine, you have theta plus theta, theta plus theta this way. So we have z squared, which is equal to r squared. We have what? Cos theta plus theta is what? 2 theta plus I sine what? 2 theta. What about z to the power 3? Z exponent 3 is the same as what? Z is the power 2 times z, which is equal to, because z to the power 2 times z to the power 1 is the same as z to the power 3, because 1 is here. So 2 plus 1 is what? Is 3. Is that not so? Good. So this is the same as, so z squared, what is z squared, viewers? Z squared is the same as this. Here is it, okay? So I have r squared multiplying this, I have cos 2 theta plus I sine 2 theta. This way, so I have z squared times z. What is z? Z is here, times z, which is r. Then we have what? Cos theta plus I sine theta. So I can say that z cubed is the same as r squared times r is what? This is r is the power 1. So I have r is the power 3. Then I have cos 2 theta plus theta. So I have 2 theta plus theta. Is that also? This way, I have plus I sine, I have 2 theta plus theta. Then finally, I'm getting z cubed is equal to r cubed, then I have cos, what do you have, 3 theta plus I sine 3 theta. What can we deduce from here? So I can say that I have, it says z to the power 3 is equal to r is the power 3. We have cos, and we have 3 theta plus I sine 3 theta this way. So I can say that, z raised to the power, let the number represent n, okay, n, because n can take any value. N can be 100, 1,000, 200 or whatever. So let n represent the power, which is equal to, then r raised to that power, which is what? Which is n. So you have it this way, n, then multiplying, I have cos the number 3, which is what? My n. Because I said the power n is equal to what? The power, okay? Then times my theta, okay? This way, then plus I sine, then 3, which is the number n, times what? The theta this way. Viewers, this is the de Moivre's theorem over here. Viewers, this is the end of the tutorials. See you next time. Bye.